Shut up, Mash.
Check. Hey, volume levels work. Okay. Nice. All right.
Wait, are you filming?
I am. Okay, if you're curious, this is just a screen capture. It's not like a camera or anything like that. It can hear your voices, yeah. I think it can hear your voices anyways. Okay, so we're supposed to find relative extrema on an interval. So question 1, we're looking at the interval from 0 to 2 pi. And we have y equals x plus cosine x. Okay. So dy dx, oh man, occasionally this happens. Okay, so dy dx then is 1 plus, oh no, it's 1 minus sine x. And for critical numbers, we set that equal to 0. So in other words, when is sine x equal to 0? That occurs when x is equal to 0, pi, 2 pi. Whoa!
Is sine x equals to 1?
Pi over 2.
Yes, and it should be only pi over 2.
And 3 pi over 2.
No, but if it was 3 pi over 2, it would be negative 1. And then it would be...
We're not there yet. Don't be hasty. We got to figure out which ones of these are mins and which ones of these are maxes. Oh no, it's supposed to find all relative extrema. Oh, okay.
Oh my god, relax.
So, oh, -1. Yeah, you're right. I see what you're saying. Okay. And we need to figure out if that's the relative minimum or a relative maximum. So we can use a first derivative test if we wanted to. This is a very small interval. 0 to pi halves. Pi halves to 2 pi. And let's just see, this is now y prime. So from 0 to pi halves, oh, what am I saying? We need those to be rounded.
Yeah,
Shall we plug in 5 or 4?
Okay. Okay, so if I say, let's say pi over 4, we have 1 minus the sine of pi over 4. Sine of pi over 4 is root 2 over 2. So 1 minus root 2 over 2 is, well, what is root 2 over 2? 0.7?
It's positive.
So 1 minus about 0.707 is positive. It's got a number in here between pi halves and 2 pi. Let's just say pi. Sine of pi is -1. 1 minus -1 is positive. So no relative extrema. Critical number. At x equals pi halves, no relative extrema. Questions? Number 2. A spherical snowball is made so that the volume is increasing at a rate of 8 feet cubed per minute. Find the rate at which the radius is increasing when the snowball is 4 feet in diameter. So we want to know dr dt when the radius is 2. So let's get our volume formula for a sphere. The volume of a sphere is 4 thirds pi times the radius cubed. That means dv dt is 4 pi r squared dr dt. You'll substitute 8 equals 4 times pi times 2 squared dr dt. 2 squared is 4 times 4 is 16. 8 over 16 pi is 1 over 2 pi. Hello. Yeah.
What patients should we memorize for tomorrow's test?
Everything. For the most basic geometric shapes. Solids. Yeah. I might.
So we have to remember.
Should we just focus on volume, or will we need to know surface area and volume?
Surface area you should know also. All right. Anything else with number 2? Number 3. Number 3. Product of 2 numbers is 800. Find the 2 numbers if the sum of the 2 times the first and 3 times the second is a minimum. So our job is to minimize f of x. We can turn f of x into an equation of one variable by substituting. I feel like we just did this equation. Okay. That means f prime of x equals 2 minus 2400 over x squared, which is 2x squared minus 2400, the whole thing over x squared. Okay, and that gives us critical numbers. Critical numbers, x equals 0, negative root 1200, positive root 1200. We're also told that x is a positive number. So if x is a positive number, we're going from 0 to positive infinity. So let's see, x 0 to root 1200, and then root 1200 to positive infinity. And we're going to hope that f is a relative minimum here. If it's a relative maximum, then this problem is a little bit bunk. So something between 0 and root 1200, let's just say 1. So if I substitute 1 here, I get 2 minus 2400. Yeah, that's negative. All right, and a number bigger than root 1200, let's say 1,000,000. 2 times 1,000,000 squared minus 24, yeah, that's positive. Remember, you don't actually have to compute things, you just have to know positive or negative. So using a number like 1,000,000 makes sense. All right, so it looks like we have a relative minimum. So f of x is a minimum when x equals, see, the square root of 1200 is 20 times 3, right? 400 times 3. Questions on number 3? Okay, let's take a look at 4. Open intervals of increase and decrease. F of x is x over x squared plus 9. Let's get a domain. Are there any holes? No. So it seems as though x is all real numbers. Right? Okay, f prime of x, low d high, minus high d low, over the denominator squared. So f prime of x, at x squared minus 2x squared. So I think that's 9 minus x squared.
Yes.
Giving me critical numbers at x equals -3 and x equals 3. Pause for questions. Okay. So we're going to do a first derivative test without actually drawing a whole lot of conclusions. Negative infinity to -3, -3 to +3, 3 to positive infinity. And we're going to examine the derivative in each of these. Let's try negative infinity, or negative 1,000. 9 minus negative 1,000 squared is 9 minus a really big number. So negative. Denominator is already squared, so denominator is always positive. Negative over positive is negative. Something here between -3 and 3 would be like 0. Positive over positive. If we use 1,000 again, 9 minus the square of 1,000 is negative, over a positive number is negative. So it seems as though f is decreasing. Let's just type this. F is decreasing for x. Darn it. X between negative infinity and -3, joined together with 3 to positive infinity. F of x is increasing for x between -3 and 3. Yeah. No. No, it feels good over here. Any questions? Okay, how are we doing so far? Five. Find short. Should we do this one? Yeah. Find shortest distance between a point and a parabola. Let's remember the distance formula. That's going to be the square root of 3 minus x squared plus 3.5 plus x squared squared. So remember that y is equal to negative x squared, giving us a graph that looks like this. So that point down here is x comma y, which is the same thing as x comma negative x squared, since y is equal to negative x squared. Yeah. They tell you. Because the point is on the parabola. Any point on that parabola would be that, yeah. Yeah.
How do we graph a parabola?
Well, it's negative x squared, so it's just a standard parabola shape, opening downwards.
Like a different type?
Possibly.
Can you give us an example of what you would do?
X squared plus 9. 9 minus x squared. Okay, we want to minimize our distance, so we'll need a derivative. F prime of x is going to be 1/2 times the radicand. Oh, you know what? We did this during period 5, and that made life a lot easier. Let's simplify our radicand. So f of x is equal to 9 minus 6x plus x squared plus 3.5 squared plus 7x squared plus x to the 4th power, all to the 1/2 power. Let's do it like this instead. All right, so that's my f of x. Let's simplify that. Let's see, we have 9 plus 3.5 squared. What is that? 9 plus 3.5 squared. This is 3.5 squared. 2125. $21.25. Let's see, let's combine all the x's. I just got that 1, right? Plus 8x squared.
Need to be mean to your student. I just thought you weren't here, so I wasn't letting them in. There's two, a young lady and a young man, so.
Okay. Okay.
Now we'll know next time.
Okay. F prime. That's 1/2 the radicand. To the negative 1/2 times the derivative of the radicand, which is 4x cubed. Okay, looks like I can simplify by a factor of 2. Hello. So what is that? 2x cubed plus 8x minus 3 Okay, we want to know when this is equal to 0. So let's do 2x squared, 2x cubed, plus 8x minus 3. We want to set that equal to 0 and solve that with our calculator. You cry and you move to the next problem. You can't do this without the calculator. Can someone see if that's one of us at the door? Sure. 2x cubed plus 8x we got 0 there. Okay, how are we with solving this? This is our graph. We're going to locate an intersection. Here we go. 0.363. 363.038. Yeah. So we're going to do the intersection again.
Mr. Ferrier, I have a question.
Yeah.
On my graph, I have a bunch of squares next to the graph.
Push y equals. Scroll up. Push enter. Enter. Push graph.
Now I have a bunch of other squares. Oh, no, I don't know.
Do you know what to do?
Okay, wait. How do you find the answers on the grade?
Yeah, I
Okay.
got it.
All right, so here's what we're going to do. We're going to do this again to find our intersection. We're going to put our two the left side of the equal sign on the y1. We're going to put the right side of the equal sign on y2. And if you're keeping track, I think this is the 4th or 5th time that I've explained how to do the exact same calculator function. So someone's not learning. All right, so we have y1, we have y2. We're going to push zoom 6. And we want to start off at zoom 6 because we have no idea what the graph is going to look like. Zoom 6. I'm going to pause here and wait for you all to be paying attention. So are you on board yet?
What is that table where we can like change like X, Y, and like how big it is and how small it is?
Table. Table. Okay, I'm going to continue. Please listen. We're going to go second, calculate number 5, which is intersection. And then our screen's going to look like this. Notice how I have a screen where it says first curve and it's just waiting for me to do something. It's asking me a question. You answer by pushing the enter button. So push enter. Now it's asking me another question. You answer by pushing enter. Then it's going to ask me a third question. You answer by pushing enter. Then it gives you the intersection. You are only really interested in the x value. X equals 0.363038. As many as you can. I don't know if this is a final answer or not. I can't hear you. They look different. Well, they're not the same. You would use this instead of the solver if there are multiple points of intersection. Remember what I said when we first started solver? I said solver only gives you one point of intersection. What is going on?
Jack tried doing it.
Okay, so you only have one curve here. Oh, you know what? You see that? You're running an application.
Oh,
That application is a transform application.
okay.
Try it now. See if it works. Okay. Are there any other questions? I can't hear you. No. Zoom 6. Trust me. Yeah.
So that's the x point. How are we trying to y?
The y coordinate is 0. No, wait. No, I'm sorry. The y coordinate you're going to substitute into the equation.
The original equation?
Well, remember what we said. The y is equal to negative x squared.
Oh, right.
Which is how come, to go back over here, this is how come we did not just use 3 decimal places. Okay, and if that's x then, y is equal to negative x squared because it's on the parabola, which is equal to the negative of 0.363038 squared. Yeah.
If the equation of the parabola was like y equals x squared plus 9, what would be our 2 points? It would be like 9, 0, and then x, y, or whatever it is.
I don't understand your question.
Like if the equation like for this parabola is y equals negative x
Can we finish this problem before we actually do all that? Okay, and let's take that number. Okay, if you notice when you go to the home screen, when I push X, it'll probably still have that number in there. So right now, if I'm only going to do one calculation, and that'll give it to me with all accuracy, all decimal places intact. So I can just square that. That's 131796. Negative, yeah. Okay, question. Yeah, Adam.
So like, let's say the problem's equation was y equals x squared plus 9. How would that like affect that? What would be like the points we would have to use?
What do you mean point?
Like for this one, the vertex, or like 0, 0 for like the point that we're using for the parabola, or like when we're graphing it. But if it's y equals x squared plus 9, would it be 0, 3 or
0, 9.
0, 9?
Okay. Yeah. Okay. Okay, shall we move on? Okay, let's take a look at I'm only going to look at the first 3 digits. You can write whatever you want. I'm only going to look at the first 3 digits. Okay. We need a linear approximation. We want to approximate f of 3.5. We're given the following information. We're given that f prime of x is 2 sine of x squared plus 3 cosine y. And we're also given f of 3 is equal to 1.5. So it's a tangent line approximation, so we'll need the equation of a tangent line. We'll have to know an x, we'll have to know a y, we'll have to know an m. This problem nicely just tells you x and y. Tells you x and y are those 2 values.
The test tomorrow, will you tell us?
I really need to keep going, so I'd be glad to answer your question when I'm finished doing what I'm doing. Let's not break up the flow. M equals 2 times sine of 3 squared plus 3 cosine of 1.5. Okay, so none of these are standard angles, so we're going to have to compute this. Let's compute. First, are we in radians? Yes, we are. Next, 2 times sine of 9 plus the cosine of 1.5. Oh, 3 times. Okay, so that gives me that as my slope, 1.036. I'm going to take that number and store it as m. I have a feeling I'm going to be using it. Make good use of storing. $1.036448. That means my tangent line, y is equal to 1.036448 x minus 3 plus 1.5. And that tells me that f prime of x, no, f of x can be approximated by, sorry, what number am I supposed to approximate?
3.5.
F of 3.5 can be approximated with 1.036448 times 3.5 minus 3 plus 1.5. I'm not going to take any chances, and I'm going to use my calculator to compute that. There we go. Okay, so it's m times a quantity of 3.5 minus 3 plus 1.5. Make good use of your calculator. 2.018. Okay, I think that answers all of question 6, right?
Yeah.
Let's take a look at question, or do you have any more questions on this one? Did you still have a question? No?
Oh,
Okay, question 7. The volume of a right circular cone is given by this equation. For this particular cone, the height equals 8/5 the radius. Find dv dt for these conditions. All right, let's do 7. Okay, so the volume of the cone is 1/3 pi r squared h. The height is 8/5 the radius, meaning the volume can be simplified into 1/3 pi radius squared 8/5 of the radius. It's 8/15 pi r cubed. Okay, we're supposed to find dv dt, so let's dv dt. That's 8/15 pi times 3r squared times dr dt. So we're just going to substitute stuff we know now. Currently r is 5 and dr dt is -3. I'm not going to take any chances. I'm just going to calculator. Let's do the numerator first. 8 times 3 times 5 squared times 3 divided by 15. So we got 120.
yes.
So that tells me dv dt negative 120 pi. Do we have questions on 7? Let's look at 8. Here's our lamppost problem. So I'm going to go ahead and draw a very simplified diagram. This is 20 feet tall. Alexis is 5'7". We don't know any of these heights, so I'll just label them X and Y. I'm assuming Alexis and the pole are at right angles with the ground. So that gives us two similar triangles. 5.7 to X is equal to 20 to X plus Y. Or 5.7x plus 5.7y equals 20x, or 5.7y equals 14.3x. Let's take derivatives. We're going to take derivatives with respect to time because we want to get a rate. The derivative of 5.7y is 5.7 dy dt, 14.3 dx dt. So they tell you that she's walking towards the light at 5 feet per second. Okay, so she's walking towards the light at 5 feet per second. Well, which one is... This is her here, right? So she's walking this way. In other words, y is the one that's decreasing at 5 feet per second. So dy is negative 5.7, negative 5, 14.3 dx dt. And let's calculator that. That's 5.7 times 5 divided by 14.3. That gives me negative 1.993. It says to round by the nearest 0.5 feet per second. So round to the nearest 0.5 feet per second. That's negative 2 feet per second. That sounds pretty fast. Yeah?
Why did you use negative 5? How do you know?
I know I'm using negative 5 because in my diagram, the value...
Tristan Sarkisian, if you're on campus, please come to the dentist's office. Tristan Sarkisian.
Okay, so if I'm looking at my diagram, the value of y is decreasing. y is getting smaller. Yeah.
So when do we use the 10 feet, the basic right?
We don't. Okay, 9. As the balloon, the shape of a sphere, is blown up, the volume is increasing at a rate of 4 inches cubed per second. Yeah.
The answer on the back is not.
Yeah, it's wrong. It's wrong. Number 9. Okay, and the volume is increasing at 4 inches cubed per minute. So that says dV dt is equal to 4. And we want to know dr dt when r equals 1. When r equals 1. So let's get our volume formula for a sphere. That's 4/3 pi r cubed dr dt. Let's take our derivatives. dV dt equals 4 pi r squared. Whoa, what the heck? 4 pi r squared dr dt. And substitute what we know. 4 equals 4 pi dr dt. And it seems as though dr dt is 1 over pi. Inches per second. Question for 9. Ten. Okay, so you're building a pen to house goats on a ranch. Using the side of your barn and 3 sides of a wooden fence, you want the pen to be 1,000 square feet. So in other words, the pen's going to look like this. And your pen is going to be 1,000 square feet. Okay, so the amount of fencing that we use is going to be 2x plus y. Bye-bye. We can substitute for y. So that becomes 2x plus 1,000 over x. So did I answer part A yet? Oh, no, I haven't. F prime of x is equal to 2 minus 1,000 over x squared, which equals 2x squared minus 1,000 over x squared. Okay, we want to minimize, so it would be nice if we had a domain for x. Unfortunately, that's not really going to happen. So we're just going to hope we have a relative minimum. Let's see. We need critical numbers. Okay, critical numbers. When the numerator is equal to 0, we have 2x squared equals 500. So negative root 500, positive root 500, and 0. We do know that x should be a positive number. It doesn't make sense for x actually to be equal to 0 or for x to be negative. So we only need to look for values of x's from 0 to positive infinity. So if I look at a number in here, let's put in 1. 2 times 1 minus 1,000, yeah, that's negative. Put in a number here, let's say a million. 2 times a million squared minus 1,000, that's positive. So it looks like, yeah, we have a relative minimum. Sorry. So if x equals root 500 and y is equal to 1,000 over root 500, is that 10 root 5? So if I divide this by 10 root 5, that's 100 over root 5. 100 root 5 over 5, 20 root 5. All right, so question A. What's the minimum amount of fencing you could use? So minimum fencing. That was equal to 2x plus y, if I remember correctly. Which is so the minimum amount of fencing looks like it's 40 root 5 feet. B. Hmm?
Do you have to do the to check if it's the minimum? It's the only answer that works. It can't be 0. It can't be negative.
What if it's the maximum though?
Well, because the question asks about the
Yeah, but what if it's a maximum?
then there's no answer to the question.
None of the above is always an answer choice.
Oh. So on the test, would we be marked off if we got the right answer, but we didn't get the answer?
Yeah.
That's a multiple choice.
Yeah. Part B, what are the dimensions? So dimensions for minimum fencing. Bye-bye. It's 10 root 5 by 20 root 5 feet. And that is that. Where are we? Okay, we're going to take a small break, and then we're going to continue.